Okay, so I'm going to delete this. I hope that makes sense to you. I'm gonna close these controls here. So as you can read here, also you can refer to the hydrocarbons as those that have not only single covalent bonds, but they can have a double bond or even a triple bond. Now, when they have all single bonds, then they are saturated. When they have all the hydrogens that they can handle, they are saturated. And again, an unsaturated hydrocarbon has one or more double bonds or triple bonds between the carbon atoms. Okay, so even if you have a double bond between carbon and another element, and that happens sometimes between carbon and oxygen most of the time, that is not, first of all, it's not a hydrocarbon because hydrocarbons are only hydrogen and carbon, okay? Now, when they have oxygen, is another type of compound, okay? This is something that we have discussed before. You can have long chains of carbon atoms because they can easily form multiple bonds to other carbon atoms. So that's very common in organic compounds. Okay, let's talk about the alkenes. These are the ones that contain a double bond. If you see a hydrocarbon that contains a double bond, at least one, between carbon and carbon, of course, this would be an alkene. And I'm pretty sure that you understand why this statement is here. An alkene with one double bond has two fewer hydrogen atoms than the corresponding alkane. This is what I want to explain. If I have a pentane and I have a pentene, of course the pentene is the alkene, the pentene is going to have two fewer hydrogen atoms than the pentane. And let me ask, why does that happen? Why that happens?
Because it's a double bond.
Yes, that's correct. Because the double bond is taking the place of the two hydrogens that are not present. Look at this. What is this? What substance is this?
Propane.
Propane. Listen, I can't wait 5 seconds for you to give me this type of answers. I made you write the list of the hydrocarbons from 1 to 20, and I expect you to know them. Like, if I ask you, what is this? You have to tell me the name in less than 5 seconds. This is propane. Thank you, Royan. And what is this now?
Propene. Propene.
Propene. That's correct. It's propene. What makes it a propene and not a propane? Well, we have a double. Yes, thank you. And notice how the number of hydrogens now is different. How many hydrogens we have in total here? 8. And how many hydrogens we have in total here?
6.
6. Where were these two hydrogens taken from? Where were these two hydrogens taken from? From the two carbons that are sharing the double bond now. Imagine that this bond here breaks off, it splits, and then you would have up here this available bond, and this bond would be available up here with a hydrogen. Now, if you want to have a double bond, you need to remove these two hydrogens. These two hydrogens disappear, and now these two bonds will just come together and form a bond in between the two carbons, okay? That would be the double bond. if you have a non-cyclic, and this is very important, because remember, if you have this structure, and this is something I want to share with you, C3H6 would be the exact same formula for the cyclopropane. Let me say it this way. If I have this triangle is a cyclopropane. Imagine that you have a carbon in every corner, have a carbon here, have a carbon here, and you have a carbon here. Actually, I'm gonna write it. C, C, and C. How many hydrogens can each of them have? How many hydrogens can this guy have? Sorry?
Two.
Two, that's correct. So I'm gonna just put CH2. And if I do the same thing in all three of them, how many hydrogens in total will I have?
Six.
Six, that's correct. So let me tell you something. This formula would be C3H6, but this is not a propene, it's a cyclopropene. What happens is that the hydrocarbons, the cyclic hydrocarbons, have the exact same formula as the alkenes with the same number of carbons. Notice that the propene and the cyclopropane, this doesn't have a double bond, but because it's cyclic, it has the same number of hydrogens as the alkene corresponding to the same number of carbons. Is that clear? Is that understood? Yes?
No.
No? You said no?
Yes, I said no.
I didn't hear your question.
Okay. Okay, my question was if it's clear that the formula for the alkenes is the exact same formula for the cycloalkanes with the same number of carbons. The cyclopropane has the same formula as the propene because they both have 3 carbons and 6 hydrogens. And this is what we call, I don't know if you remember that we name this. What is the name of these compounds that have the same molecular formula but different structural formula? Anybody remembers?
It start with an I.
Isomers, okay? Isomers. They have the same the exact same molecular formula, but when you draw the formula, the structural formula, they are different. These are isomers. Remember that, please. Thank you. Okay, so the general formula for the non-cyclic alkenes with one double bond is CnH2n instead of CnH2n plus 2 as it is for the alkanes. There are 2 things that I want you to notice here. Number one, we already did that, is knowing that we're talking about non-cyclic alkenes. That means if you have a cyclic alkene, let me go back to the propane, to the cyclopropane, and now you have a double bond here. Have a double bond here. My question is, how many hydrogens will this guy have? This carbon, how many hydrogens can it handle? Hola. No. How many hydrogens can this carbon has? Let's see. It's
One.
only one. Thank you. Only one. So notice that now we can't stick to this formula if it's a cyclic alkene. Okay, a cyclic because it's a ring. Okay, it's a cycle. And it's alkene because it has a double bond. When that happens, the number of hydrogens is not going to be the same as if it has a non-cyclic alkene. How many hydrogens will this guy have now in total? How many hydrogens is it? Wait, is anyone there? Hola. Hello.
Can you repeat the question?
I'm sorry, my internet connection is misbehaving today. That's why we missed that. But I was saying before we got the problem with the connection is that this is talking about non-cyclic alkenes, because the moment this turns into a cyclic alkene, of course, you know, you will have to lose 2 more hydrogens. You already lost 2 hydrogens here in order to have this double bond. Now, if you make this, if you make it a cyclic hydrocarbon, like I was doing this, and you have a double bond here, how much hydrogens are you going to have here? It's going to be 3 carbons still, but how many hydrogens is it going to be? Can
4.
Yes, it's just going to be 4. So notice that this formula here doesn't apply to the cyclic alkenes. Okay, you have certain number of carbons, and the double of the carbons is going to be the hydrogen. So if you have 3 carbons, you will have 6 hydrogens in the alkenes. But if this alkene is a cyclic alkene, then the formula is not going to be applicable to this. Can you still hear me?
Kind of breaking up every now and again, but we're hearing you enough.
Okay. All right, so just to make sure that everybody understood, I was saying that the formula, this formula here, does not apply to the cyclic alkenes, because the number of hydrogens is not double of the carbons that you have here, as you have it in the non-cyclic. This formula is for the non-cyclic alkenes. Now in the cyclic alkenes, it has to be something different. That's the first thing that I need you to notice when it comes to the alkenes. Now, something else is that it says that this formula applies when you have only 1 double bond. Because if we lost 2 hydrogens for us to have a double bond here, what do you think will happen if we have a second double bond here? Are we going to still keep the same number of hydrogens? You will lose 2 more hydrogens.
No.
You will lose 2 more hydrogens. Okay, so every double bond that you have in a structure will mean that you will have 2 less hydrogens. Let's say, for example, that we have here this structure C, 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 C. Okay, how many carbons are there? I didn't count them. I think it's 8. Check that for me. Is it 8? Hope so.
Yep.
Okay, now how many hydrogens would this have if it has only 1 double bond? Let me remove this double bond from here. Just leave 1. How many hydrogens would it have there? Remember, based on the formula that
14.
I'm sorry?
We have 14. We would have 14.
No, with only 1 double bond, please. Remember our formula here. The formula says CnH2n.
15.
You say 15 as 1,5?
15.
15.
Yeah.
No.
I say
No.
16.
16.
16. Come
16.
on. Come on, guys. 16. The formula is there. Cn, where n is any number of carbons that you have. H2n. If you have 4, the hydrogen is going to be double of 4, 2 times 4. If you have 10, it's going to be 2 times 10. If you have 8, it's 2 times 8. Therefore, it's 16. I thought you were playing me around. Okay, so this is going to be 16. And yes, the formula applies to this because it has only one double bond, this one. Now, if we have a second double bond here, how many hydrogens is it going to have now? How many hydrogens?
14.
14. Thank you.
14.
Yes, thank you. If you don't believe me, you can just go ahead and draw all the hydrogens that you have there. And you will notice that this is the number of hydrogen that you have. 1, 2, 3, 4, 5, 6, 7, 8. Only 1 to this, okay? Because we have 1, 2, 3, and this is the 4th. And only 1 to this. How much I have so far? Let me see. That's 6, 7, 8, 9, 10, 11, 12, 13, and 14. Okay. Am I missing any hydrogen here? Did I put any hydrogen that I wasn't supposed to put? Is that correct? That's my question.
Yes.
Yes, correct.
If I put a next hydrogen, a next double bond, let's say here in between these two, I will lose 2 more hydrogens. Notice that if I don't, then this carbon would have 5 bonds, and that's not supposed to happen. The most they can have is 4. Notice this carbon that has 1 bond here, 2, 3, 4, and 5. That's why we need to remove one of these hydrogens that we have here. And the same thing for this carbon. No. Okay. Oh boy. Anyway, you know that hydrogen is no longer there. Okay, so I hope you understand this part. If you have any questions, feel free to ask Google or myself, especially when I'm not available. Okay, so let's move on with this. This formula only applies if you have a non-cyclic alkene, because the moment is a cyclic alkene, then the number of hydrogen will decrease. And if you have more than 1 double bond, also the number of hydrogens will decrease. 2 hydrogens are lost every time a double bond is present in the chain. Is that clear?
Yep.
Okay. Okay. Now, how to name the alkenes? Is the exact same rule as for the alkanes. You have to find the longest chain. This one has to contain a double bond. Okay. So look at this. Even though here you have a longest chain, because you would have 1, 2, 3, 4, 5, and 6 carbons, because you don't have a double bond here, you have to continue straight. Okay? This wouldn't be the correct one. Why? Because a double bond has priority, has preeminency over the branch that you might have here. Okay, so your chain continues straight instead of turning up. Is that clear? Wherever you have the
Yes.
double bond, this is where your main chain is going to go. Now, which carbon is going to be carbon number 1? Is it going to be this one or this one? This is a common sense question. The one to the left here or the one to the right here? Which one is carbon number 1? Because remember, after you identify the longest chain, you have to number the carbons. So I'm asking, which one is carbon number 1? The one to the left or the one to the right? Can you guys?
The,
I'm sorry, I didn't hear that.
I was asking if you could repeat the question again.
Oh, yes, I'm sorry. Remember, my internet is misbehaving today. It's acting LGBT, Q, R, S, T, U, V, W, X, Y, and Z. So when I ask a question and I don't hear you back, that means that either my internet connection is lost or you don't want to speak. So let me repeat the question. Even if you don't know the answer, let me know that you heard my question. My question was, which carbon is going to be the first? Because after you have identified the longest chain, you have to number the atoms in order to name the compound. So which carbon is the first one? The one to the left or the one to the right?
Oh, the double bond.
Of course, it's a common
No, the
sense
double
question.
bond.
This one, this is carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. Okay, so this is a pentene and not a hexane. It has 5 carbons, the longest chain, and not 6, because I have to include this in the main chain. So let's move on. We have to number them, and as Mr. Christopher told us, this will be carbon number 1. Okay, after we have numbered the carbons, now we'll look for the branches that we might have, and we do have one.
I didn't hear what you said.
Can you repeat what you just said?
Sure. I just said that after we have numbered the carbons, now we look for the branches that we have. Do we have any branches here? Do we have any branches here?
Yes.
Yes.
What type of branch we have here? What's the name of that branch? What is the name of that branch?
2FL?
Okay, the branch we have is ethyl, and it's located in carbon number 2, as is written here. The position number and name of the alkyl group, this alkyl group, remember, this is the branch. And it's an alkyl because it's not an alkane. Alkanes are the main branches. Alkyl are the main chain, sorry. Alkyls are the branches. And of course, you have to name the branches first, and then the last thing you mention in the name is the main chain. So notice that we say 2-ethyl 1-pentene. Let me ask, what is this 1 for? Anybody knows? Can anybody tell me?
The double bond?
Yes, this is the location of the double bond, as is stated here. As it's stated here, you also have to state in which carbon is a double bond. Now notice something. This double bond is in between carbon number 1 and carbon number 2, but you will always mention the lowest of the 2 carbons that you have, right? That's why we say 1-pentene instead of 2-pentene. And we have to say where is this double bond, because not in all the cases it's going to be in the first carbon. Sometimes it's going to be in the 3rd carbon or in the 4th carbon. Of course, let me tell you something. This is very important. If this, let me see who is thinking here, who had their breakfast this morning. If this double bond, are you guys hearing me? Because I want to make sure that everybody's listening. Okay.
Yeah.
If this double
Yes.
bond now is here, follow me, please. If this double bond is no longer there, but here, what is going to be the name of this compound? Let me see who had their breakfast today.
Ethanol, one hexane,
Repeat, please.
2 ethanol, 1 hexane, hexane.
No, 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 no. We have the double bond here now. Oh, I'm so clever. We have the double bond here now. And not here. It's gone from here. I have a single bond here, and now the double bond is here. What's the name of this compound now? You're gonna be hearing and typing here.
Number it?
What is that?
Wouldn't you have to renumber it?
Yes, thank you.
Repeat that? I didn't hear anything.
You would have to renumber it, so then it would be 2. I mean, it would be 4 ethyl, 2 hexane,
Hey, why we have to renumber it?
because the double bond is closer to the other side.
Yes, now the double bond is closer to this end. So now you don't start counting from here, but from here, because it has to be which end has the closest double bond in this case. And why are you still saying hexane? Huh? Hola.
Is it not?
Because
Why are you still? Go ahead.
because the longest chain would be the branch.
Oh, yes, yes. What? I didn't see that. You beat me this time. Yes, it's hexene. Wow, you're right, and I was wrong. So this is not ethyl then. This changes. This is not ethyl now. What is this?
Methyl.
Methyl. Good. And I'm pretty sure that at this point, some people are like, okay, what are we doing here? I'm lost. I'm confused. First of all, let me just go back over this quickly. If the double bond is not here, but here, that means we have to start counting from this end now and not from this end. But even before we number the carbons, we identify the longest chain, which is no longer this one. But now it's going to go up because I didn't go up before because I had the double bond here, but I no longer have the double bond here. I have it here. So that means now I can go up, and that will make it a 6 carbon chain. So it's going to be a hexane, first of all. Second of all, I have to number the carbons. And of course, the double bond has to be closer to the end that has carbon number 1. So of course, this is going to be carbon number 1, carbon number 2, carbon number 3, 4, 5, and 6, right? And then we have to look for the branches now. If this is the main chain, do we have any carbons that is not part of the main chain? Yes, this one. By the way, this number of hydrogens also has to change, right? Are you with me? Are you with me? Hola. The number of hydrogens will also change
Yes.
to 3, okay? So this is going to be H3C. And I'm pretty sure that you might be wondering, why is H 2C and not CH2. This is because if you put the hydrogen in between, you will be saying that the hydrogen is combined with this carbon and also with this carbon, and that is not true. It's the two carbons that are combined, and then the hydrogen is just part of this carbon. But that wouldn't be any problem if you ever have it here. I wouldn't ask you, I wouldn't penalize you for that. Okay, so we have this branch here, which is a methyl, and it's located in carbon number 4. Carbon number 4 because we started counting from here. 1, 2, 3, 4, 5, 6. So we have a methyl in carbon number 4. 4 is going to be 4-methyl, 2-hexene, and this 2 is because of the double bond that is located here. All right. So that's the explanation. Any questions? Anything that you didn't understand about this before I end this section of the meeting? We'll have 1 minute to answer any questions. Anything that you didn't understand well? Is all clear? Is all clear?
Yeah.
I guess for the most part.
Okay. Okay, amigos. And this is something that I'm going to explain to you when we come back, because I'm going to end the meeting. We have less than a minute. I'm going to end the meeting and resume immediately. So join me back one time.